how it is between students and teachers? Thank you. Take a seat. Now, last lesson we looked at force, lesson number 1. Now, you can tell me what is a force? William?
Force is a pull or push.
You agree? Yes. So, force is a pull or a push. Now, the strength of the force is shown by the length of the arrow. A large arrow means a strong force, and a small arrow means a weak force. That is because we cannot see what actually a force is. Right? We can see the result of the force or the effects of the force, but we cannot actually see it. So it's very difficult. Force, when we talk about force, it's very difficult to try to work out what is a force. So, or even to see it. So the simple definition is force is a pull or a push, and it can be represented by using arrows. Now, have a look at these 3 pictures. We have someone playing cricket, and there are 3 different pitches there where direction and the size of force is involved. I've labeled them A, B, and C. In a cricket game, a ball is being bowled, and the player tries to bat by hitting the ball away. All right, so there's some sort of force being used in there. Now, if you have a look at this, A, B, and C, which force involved there is smaller? A, B, or C? A. A is smaller. What happens in here? Okay, the batsman is maybe just blocking it. And which is the larger force in here? The largest force? B. B. Okay. The player there is striking the ball. And we have C, which is in between A and B. Now, we cannot describe how big, how small the force is, because we don't see the force, but we see the effect of it. Are we following? Yes. So we indicate by an arrow to show whether the force is big or small. So you can see the arrow in here is small. The arrow in here is bigger than this one and bigger than this one. So that means this is the largest force. And you can see the direction, the force of direction going this way, shown by the arrow. The force, the direction of the force is going this way, and the direction of the force is coming this way. So the arrow shows the direction and the size of a force. Today's lesson, we will still look at the topic on force, lesson number 2. In this lesson, this is some things that we will have to do. We will predict different forces on spring balance. How many of you have seen a spring balance? All right, receiving students, and if you haven't seen a spring balance, you will be able to see one soon. We will test the forces of different objects on the spring balance, and we'll discuss and explain the findings from those activities. The materials needed for this lesson, what we have now is we don't have oranges, we have soap. If you can bring a drinking cup, and in this case we are using the coffee bottles here, which can also be used as cups. And we have dry cells, 6 of them been taped together. Spring balance. And we don't have a beam, but we have a retort stand here. We will be using it, but because many schools don't have, you can make your own, or otherwise you can go outside and use something to hang the spring balance on. So that's what we will do in today's lesson. In our main activity, we will be going out, working outside the classroom. So these are the materials that we will use in this lesson. Let's quickly go through the instructions. Before we go through, let me have the runners to come up and get your materials. So we will do some, I will do some explanations on how you will use this. Runners for each group. Receiving students and teachers. We have 10 groups in the model class, but at the moment we have combined the groups due to the materials. So there are 2 groups working as one. Predict what will happen when different forces are put on the spring balance, and give your prediction for your, give your reasons for your prediction. So you must give your reason. You will use the materials as your force in a simple experiment. So those materials that you have are the cup, the dry cells, soap, all those materials will be used as force. Okay, you will use this as force. This is the step that you will follow. You will have the spring balance hanging from the beam constructed. Right? We have the spring balance. Before we try to hang it, I'd like you to look at the spring balances that you have. We have a pointer in the middle. If it's not on 0, first of all, we will have to adjust it. There's an adjuster at the top. You can pull it down or up and adjust it to 0. Let's look at what is in the spring balance. On the right side of the spring balance, the measurement is in grams. So we have 0 up to 1,000 grams on the right side of the spring balance. On the left side, the measurements are in. Can you put that away and listen, please? I just asked you to get out the spring balance. I'm explaining something here which is important, and you've got to understand this. On the left side, the measurement is in newtons, right? Newtons. And you will see it's from 0 to 10. Now, my question here is, how will you find the measurements in between those numbers? For the numbers, it's okay, but there are divisions between numbers. How will you find them? For the gram, let's have a look at it. We have 0, between 0 and 100. What's the first division? How many are we going to count by? We are going to count by 20. We're going to count by 20. So your spring balance should have something like this. On the left side, you have in grams. On the right side, you have in newtons. Now, if your pointer is around here, what reading would you give? So that's the thing I'm talking about, the divisions. You've got to know by how many should you count. So this one division will be equivalent to 20. So we have 20, 40, 60, 80, and 100. This would be 120. Now that's for grams. How about newtons? .2. So if this is 0.2, this is 0.4, 0.6, 0.8, 1, 1.2, 1.8, and 2, and you continue. So that is the way to read it. You will have the spring balance hang from the beam constructed. We will go outside and show you there. Put each of the force on the hook of the balance. Observe the pointer as the spring stretches until the pointer stops moving. You will read off the size of the force from the scale. Record the size of the force in the table provided. This is the table. Receiving students, you can get this table quickly into your exercise books or notes books. If you don't have the materials, you can find at your own time and try these experiments out. All right. With that, we will move out. As I've stated, you have 7 minutes, 1 minute to move out. You will carry the activity out for only 5 minutes, and then you will come back. All right, before we move out, I'll give you about a minute to get this table into your exercise books. Quickly predict. Now you have the spring balance there. Get each of the materials and you predict. Predict, and after you predict, you explain your prediction before you can carry out the activity.
You don't have any orange. You don't have any sugar.
We should have one if we brought
Which force is bigger? Which force is bigger is the drive 6. So go 1, 2, 3, 4, 5 like that. Just number them. Predict. Just the ones that they brought, not the ones that you don't have.
Predict some more.
Size of force.
How can we predict? Don't predict.
1, 2, 3. Because you don't predict. You don't copy.
First.
You don't copy.
Ah, boleh. Give me going. I'm predictor. Are you really gonna keep going?
I'm gonna write it there. I'm gonna say.
Yeah, maybe inspire me again.
I'm a prediction.
Come here.
1
100 grams.
100 gram, 1.2.
You're writing, yeah. Just writing slow.
Don't you have
You're writing. Why are you writing 1.1? Just writing 100 gram now, one string. What then? No, but writing doon, writing doon. Dapat yung water finish. Pero sino, kaya water. Okay, yeah, enough na one. Okay, next one.
Battery.
Pero kenapa dito? Masuk.
Oh, 600.
600 grams and 6 newtons.
I'm only for battery.
Sorry, predict me wrong. Come in now.
Predict me 1 at 3.
No,
600 grams.
Predict me is about 2.
No.
Number 3.
2.
Number
2
400.
or
400.
1.4.
Number 400.
Number 4, yeah.
400
Number
grams.
2.5.
Drinking man.
4.
Next.
1.4.
1.4, I think. No, you know 1.4.
Number 2 here. Meeting number 2 here.
4 grams. 4 grams.
Number 200 grams. 1.4.
You know what?
You the 2.5.
2.4, yeah.
Me too, okay.
2.5, yeah. 2.5.
2.3, but this time 4, this time 5 is so
Yeah.
1, 2, 3.
No, at 4.
Only 3.
No, 2 bastante up.
2, 4, 6, 8, 10.
But maybe this counting so.
2.5, yeah. 2.5.
Namelo 4 na 6.
2.5. 2.5, yeah. 2, 4 na mele.
Yeah, 2.5.
2.5, yeah.
6.
2.5.
Namela.
See, yeah, I mean looking 2, 4 na mele. 4 na 6, yeah.
2.5.
2.5.
250, huh?
250.
The gram also dog. 250 grams. Yeah, the
250
grams
grams.
na 2.5 newtons.
2.5. 50.
Yeah, aray mo.
50, yeah.
250 lo grams na 2.5 lo. 2.5 newtons. Yeah, no, amen.
Pay attention to the
So okay, next time. Finish it. Oh, one more. One more. Still keep the shade. That's all.
Yeah, I think that's
I think my steel tape is going there.
Yeah, I think so.
No, mine will be
5.8. Yeah. 500 grams and 580 grams and 5.8. 5 point. I don't know, yeah, you said grams and 5.8. You're right, you can. Not end.
If you are finished, you can move in.
Take a stall of water in
Take it out and put them out.
What?
Mark, come.
Wait, me go put in there. Put in there.
Emma put down.
Cute, obviously. Yeah.
2.4. 240.
20.
20 is there.
Okay,
40. 240 and 2.4. Where?
Bobby, you really get camera to the
240 and
2.4.
2.4 newtons. Okay, let's go.
Sprint balance if it's starting from 0.
Yeah, it started from 0.
Okay, that's okay. Only one group did
We'll
not adjust.
write. This one is small.
Only.
No, loose up.
Predictions because it says which force is bigger. So just tell them they can write which one they think is bigger first, that one. The next one, first, second, third, something like. They're trying to write the whole lot.
They can just take the one they think is big too. That's okay. You're keeping our time. You're keeping our time.
Okay.
0, starting from 0.
Yeah.
60.
Now you should also answer these questions. There are 2 other questions that you will have to answer. Which object had a greater force and why? If the gravity pulling on an object is smaller, what would be the size of the force? Right. So you also discuss, because this is a group work, you discuss with your friends and write the answers. I'll give you 2 minutes to do that. All right, I think it should be finished now. Now, the activity that you have carried out, you have actually found out the weight, weight, and also the force. So you have realized that the weight, you measured it in grams and the force in newtons. All right, let's have some people to tell us the prediction. Your prediction was you will predict what happens when different forces are put on the spring balance. So we use those materials as forces. What actually happened? What actually will happen? That's your prediction. All right. One of the questions was, which object will have the largest force? So what was your prediction? Let's have someone to tell us the prediction. Your prediction. What you predicted. Paul. Your group, you were working in a group, so tell us your group's prediction.
The sprint balance will go down because they have different weights.
Okay, that's what they predict. And it gave a reason because they have different weights. That's why the sprint balance will go down. Did you find out that in your activity? Did you confirm that? It did? Good. You found out that different of the all those objects have different forces involved. Now we'll try to see, because in this lesson we're not actually looking at the weight, but we're looking at the force. We're looking at the force. So the experiment that you carried out, it's in line with weight, but what we're actually trying to find out is the force. So you have a look at this. This is just an instrument. The force that we are trying to apply is here, the soap. So when we put it on the sprint balance, there are some changes being shown here on the sprint balance. That all comes back to gravity. Have you heard of gravity force, gravitational force? Yes? All right. Gravitational force. You can tell me what you understand about gravitational force. You said you heard of it. All right. Gravity is the attraction between two objects. In this case, we have this object, the soap. And what is another object? No. I said gravity is the attraction between two objects. It is the soap and the earth. The earth. There is the force between this. So you see, attraction. This force, there's a force that attracts things, objects together, two objects together, it's always there. Now, you and your friend sitting next to each other, there is a little bit of attraction force there between two of you. But you cannot feel it because your mass is small. Now, when we look at the soap and the earth, the attraction and the force between them, it depends on the size of these objects. Now, when we look at these two objects, which is larger? The soap or the earth? So, the soap will have a little force in there. But the pull of gravity, that is the force that we are trying to measure using sprint balance. Right? Any sprint balance that have readings in newtons is called a Neutron balance, all right? Because it measures newtons. Newton is a unit that is used to measure force. Now we have mass. In mass, we use the units gram, kilogram, milligram. Those are the units used to find the mass. The weight. Now, for the force, we use newtons because Newton is named after, the unit Newton is named after a person, a scientist who discovered this gravitational force and all this. So the forces. Now, this mass or this force will be different from this one. There is more to this, so it will have much more force in it. Like I said, the force depends on the mass of the object. The bigger a object is, the more force it will have. The smaller the object is, the less force it will have. To make it easy for you to find out, if someone is very muscular, very tough, you think you will have some strong force in him? Yes or no? How about that skinny guy, very skinny? You think he will have some force? The force will be there, but it will be less than the someone who is muscular. So the force is like that. The bigger the object is, the larger the object is, the more force it will have. The instrument used for measuring force is called a spring balance or force measurer. That's what we have there. Like in this lesson, we use the spring balance. We're not actually finding the weight, but we're trying to find out the force. You've seen newtons. A spring stretches when a pulling force acts on it. There are other things that I forgot to just inform you. We have been using spring balance. In a spring balance, there are springs in there, and when we apply this, or when we put these objects on, what actually happens? We pull the spring, right? We pull. So the force acting on it is, this is pulling down the spring, right? We have bathroom scale, where you can stand on it. These two are examples of kitchen scale, right? This is a kitchen scale, and this is a kitchen scale, and this is bathroom. They can also be used to measure force, but for these three of them, it's different from the spring balance. Spring balance, there's pulling force in here. What do you think will happen here? There will be pushing force. So when you put this on, it pushes down the spring. So as these two. Right? So there are scales that are used for pulling down of object or pushing. So in this case, it's pushing. So these are some of the instruments that can be used to measure force. So a spring stretches when pulling force acts on it. Our next summary point: spring balance measure pulls, and kitchen or bathroom scale measures pushes. So I have just shown you that. The size of force on the scale is the force of gravity pulling down on the object. So the size of the force on the scale is the force of gravity that's pulling down on the object. Our next summary point: spring balance, whose scale is marked in Newton, is called a Neutron balance. Now, the other point is very important. You listen. 100 grams is equals to 1 Newton. Sometimes you will not be allowed to use the spring balance, but you must always remember this, that 100 grams is equals to 1 Newton. So if there are 200 grams, how many newtons? 2. If there are 1,000 grams, how many newtons? Okay, so that's the rule you will have to remember. 100 grams is equals to 1 Newton. So you can always convert grams to Newton or kilograms to Newton. 1 kilogram, how many newtons? How many? 1 kilogram, 10 newtons. 1 kilogram is the same as 1,000 grams. Forces can be measured using the unit Newton. So we use the unit Newton to measure force. That is all for today's lesson, and our key phrase is spring balance. Our next lesson topic is on force, lesson number 3. And the materials that we will need, we will a 1 meter ruler, pencils, plasticine, and a triangular pivot. Now, I'd like to ask each group to come up with 10 groups. Recent students, you can also come up with this, a triangular pivot, which will have a shape like this. Maybe out of a timber. What we are going to do is we will try to put a ruler on here. So trying to balance things. So I need you to bring a triangular pivot. With that, thank you HCS resident students and teachers for your participation. You're welcome.